Hi, my name is Rafael Taubinger and I'm Global FAE Manager at IAR Systems. In this short video, I want to show you the IAR Universal Project Converter that can be used to migrate virtually any project to IAR. You can use it to migrate GCC project to IAR or even other competitive tool to IAR or even between versions from IAR. So the use it's very simple. If I open the IAR embedded workbench that you might already be familiar, we of course have it for different architectures, RISC-V, AVR, ARM for example, and way more. We include in our tool some project converters, but the one I'm trying to show you, it's what I said, it's the universal project converter. So the way it works is you mainly need to install this universal project converter or migration tool, and it is straightforward here, just a few steps, and then you can have everything up and running. So you of course need to select the installation folder from the IAR embedded workbench. You might have it in a different folder or customized. So once I complete this step here, it will be really straightforward. And once I open the embedded workbench again here, you will notice that there is a new menu available here, and it's named Add New Source Folder. So the way it works is mainly that it will use a source folder or a root folder, and from there mainly populate the project by following exactly the same structure by subfolders, and then all the files will be placed automatically into the project, and even the references to the header files will be added to the settings. So how does that work? I have here a project for FreeRTOS, and I will migrate this project to IAR. So how does it work? So first, what I need to do, I have here the embedded workbench, and we are going to use, in this case, the IAR embedded workbench for ARM. And I need to start by creating a new project. So I will create a new empty project, and I could place this project, of course, anywhere in my computer here, but I will of course try to follow and keep it inside the project folder here. So I will just name it as project, can be project 1. So this is the first step. It will just finalize this process here of creating the project, and what I need to do from here is to run this add new source folder. So what will happen here is that I need to point to the folder that includes all the source files and header files and everything needed for this project. And once I complete this step here, it will just create a project file for IAR, and it's already asking us to reload it. Yes, we want to do that. And once I complete this step here, you will see that the project has been completely populated here, and you can see that the exact same folder structure is being kept here, and then we of course have all the files and so on available here. So this is the first step. Next step is of course to do the project settings, and this means we need to select a device, do some adjustments maybe on the linker file, or even select a driver for debugging. So let's do that now. So what we need to do first, as I said, is to select a device. In this case, I'm actually using an STM32F429 device. I will select it here. So as you can see, the list of devices, it's huge here. So it would work for any family, any device, of course. And I can select here what I want. So this is the first step. And then of course there might be some other settings you might be willing to adjust. You can just do that. Here in this case, I also want to enable the CMSIS. Since I'm using the ST Hall drivers, I want to enable that too here. And very good here also is that aside of already creating this complete tree here of the project, it will of course also make sure to include everything about the preprocessor, so you don't have to worry about that. But then of course, since I'm using the whole driver, I know here that I need to just define this or use this macro in the project. So please check your make files or your project settings that you have from the tool from competition to make sure you're also declaring these symbols here. So I will use the whole driver, that's known, and as you saw, I'm using the STM32F4 to 9, and then I can of course use XX here to make sure that the drivers behave correctly. And final thing here, I might use some inline semantics and so on, but that's a minor thing of course. The linker file is of course here as default. I could do adjustments if I want just by overriding it, but that's not needed by now. And then of course, once my project is building fine, I want to be able to do the debugging. I can use of course the simulator, any of the other supported drivers here, but in this case I'm using the IAR iJet also. So once this step is completed, I can just confirm here and be aware then, yes, we created a project, we are including all the files, we have the preprocessor, we have the macros defined. Of course, when I start to build this project, it might be that I get some warnings still. So be aware that you still need to do some extra effort. Of course, migrating a project might take weeks, 1-2 weeks maybe of effort, but by using this tool, you can maybe reduce it to a few minutes, and I will show you how this is possible here. So I did a selection here of the device and so on, so I can start by trying to build this project, and let's see what we get here. Of course, first it asks here for a workspace. I just need to save this here, and once it starts to build, yes, of course, we already got some warnings and build errors here. And if I look here, it's mainly duplicate files here. And yes, of course, I'm using FreeRTOS here, and there is a dedicated system STM32 for it. And I don't need to use the file that it's delivered on the templates from the ST library. So if I look here, we have it under driver CMSys device. So I can just make sure that I localize here this file or even the structure, and it's under templates. We don't want to use that here, and I can just exclude it from the build. This might be very common that in the project folder you might have some files that are not really being used during the build or in your project. So either you clean it in advance or you just exclude it from the build, and that's what I'm doing here. So good, so I can go to the next step. Let's try to build now to see what we get. It's looking way better now. Some files are being built. The whole drivers, very good. So let's continue here to see what is the next step that we need to adjust. Okay, we got some build errors here, and yes, of course I can see it. It's using USB, but this project was not using the USB drivers at all. So if I look here under FreeRTOS middleware, so I can see that there is under ST this STM32 USB device library. I'm not using it at all in this project, so it's a lot of files there, and I don't need it now. Either I exclude it from the folder, but since I'm not using it until now, maybe in future, yes, I will not use it in this build. So I can go to the next step, of course. So it's linking, but I'm still getting some errors here. And if I look here on the message, of course, it's about malloc free. So it's the memory heap manipulation part of FreeRTOS. And I can see here, yeah, it's duplicate definitions in heap _1, 2. Of course, if you know FreeRTOS, that's of course here under the source. If I look under portable memory management, you should actually only use one of these, and the tool is not aware of that. Of course, it included all the files, so we need to decide what we want. Usually I'm familiar here with HIP 4, so as I said, it's all about the memory management, malloc free, the HIP and so on. I will keep this one and exclude all the others. So I can just exclude these files from the build. And we have to exclude the extra ones here too, and let's just save one file at the end here. So now we should be good. So let's see if we get a bit more looky here now if I build this. And yes, so we managed to move the project, do the settings, and I'm not getting any errors or warnings anymore, so that's a good sign. So of course you might still need to do some adjustments. You will run your application, but in this case I already selected the iJet and now I'm ready to connect to the target. So if I download my application here, I'm connecting to the target, and if everything goes well I should end on main here after the download. So the debugger is connecting, yes, perfect. We just connected to main, so all the features, registers, and all the fancy capabilities with breakpoints and so on, it's all available here. But if I leave this running for a while, I just click go here. I want to see if it's really working. Okay, we can see in the target some things happening, LEDs blinking and so on. But the best way I can show you that this is working fine, if I enable the timeline, and if I'm using interrupts and everything, it's fine. This should be available here. And yes, as you can see, we have actually some breakpoints being triggered and it is running here. So very good. As you can see, in just a few steps, by using this universal project migration tool, you can migrate projects and use it here with IAR and start exploring all the nice capabilities. Very good. So if you want to learn more or get any assistance from us, please check our website at IAR.com. We have a special section about migrating to IAR, so you can even get help from our experts. So we have many documentation here available, many documents, guides, some converting tools, including this one. And of course, you can reach out to us so we can help you further to assist you on the migration of your project. Thank you. I hope you liked this video and hope to see you soon.